Today we're going to learn about perpendicular and angle bisectors, and we're going to use their properties to solve for unknown sides and angles in triangles. The perpendicular bisector theorem states if a point is on the perpendicular bisector of a segment, it is equidistant from the endpoints of the segment. So as you can see by this right angle and these two marks, PM is the perpendicular bisector. The last part of this sentence says, then it is equidistant from the endpoints of the segment. So that is saying that if I were to draw in a triangle, A and B are both equidistant from P, so that makes these two sides the same length. The converse is when we have the same statement but we've reversed the beginning and end of the sentence. So this time it says, if a point is equidistant from the endpoints of the segment, it is on the perpendicular bisector of a segment. So this time I have AP and BP that are congruent. If that's true, that means that PM is a perpendicular bisector, so this is a right angle, and AM is congruent to BM. Using the information we just learned, we can use this to solve for missing sides or angles of triangles. So if you look at the diagram, you can see that KM is a perpendicular bisector to JL, and that tells us that these two sides would be congruent because J and L are equidistant from K. So I would set 6x minus 26 equal to 3x plus 34. I could subtract 3x from both sides. I would get 3x minus 26 equals 34. I can add 26 to both sides. I get 3x equals 60. And I divide by 3 on both sides. X equals 20. Just double checking, the original says find the value of JK. So I need to take this 20 and plug it in for X. When I do that, I get 6 times 20 minus 26. So that's 120 minus 26, which is 94. In the second example, I notice that point A and B are equidistant from C, which means that CD is a perpendicular bisector of AB, so I know that these two segments are congruent, and there's also a right angle. Since the segments are congruent, I would take 5x minus 11 and set it equal to 3x plus 17. I subtract from 3x on both sides. I get 2x minus 11 equals 17. I add 11 to both sides. 2x equals 28. And when I divide by 2, x equals 14. I need to find the value of AB, so I'm going to take this 14. And I can plug it into either side. I'm personally just going to plug it in here because I see that AB is this entire segment. So I can do 3 times 14 plus 17, which is 59. So DB is 59, which means AD is 59, and then altogether AB is 118. The angle bisector theorem says the following. So it says ray AD bisects angle BAC. So that made these two angles right here congruent. AB is perpendicular to BD, so that gave me these right angles. And AC is perpendicular to CD, so again, gave me a right angle. Then what that means is that BD is congruent to CD, so we would need to add those marks, BD, CD. The converse is if BD is congruent to CD, so those are these marks here. AB is perpendicular to BD and AC is perpendicular to CD. That gave us these right angles. Then AD bisects angle BAC. So that would mean that these two angles would be congruent. Using the information from the angle bisector theorem, we can solve for these missing sides. So if you notice, I have this angle up top is bisected. I have perpendicular lines creating these right angles, and we know that that means these two sides are congruent. So I'm going to set 13x minus 4 equal to 8x plus 11. I can subtract 8x from both sides. I get 5x minus 4 equals 11. I add 4 to both sides. 5x equals 15. And when I divide both sides by 5, x equals 3. I need to find AD, which is this segment here. So I'm going to take 3 and plug it in for x. So I have 13 times 3 minus 4, which is 35. In the last example, I have two congruent segments. I also have these right angles, which means that the angles up top are bisected. Since they're bisected, I know that they're congruent, so I have 8x minus 32 equals 3x plus 3. I can subtract 3x from both sides. I get 5x minus 32 equals 3. I add 32 to both sides. 5x equals 35. If I divide by 5, x equals 7. I need to find the measure of angle XWZ, and XWZ is this angle. So I would want to take x and plug it in for this x. So I have 8 times 7 minus 32, which is 24 degrees. Now that you've finished watching the video, you should complete the worksheet, and I'll be checking it in class on Monday.